Hello and welcome everyone to Smart Company, the podcast. I'm your host, Dave Dory, and I'm joined as always by my co-host, tech expert, Grace Schroeder. Today we're honored to have Michael Recchia, CEO of Adapnet, an exciting new company that focuses on AI, next-gen computing, networking, media forensics, that launches in Q2 of next year. Michael, thank you so much for joining us today.
My pleasure. Thanks for having me.
So, just to get started, generally what we'd like to do is hear a little bit about your career journey, your background, what got you here to where you are today. Tell us about your personal career history.
Well, I'm a techie. I'm a nerd. I've always been interested in communications, and so I got involved early on with Telecom. And in the early days, I was writing software for Telecom, mainly on some of their 5E switches, and then as the world moved on their packet switches. And so I have a background in sort of this deep technology, writing code at low level for various devices, including operating systems, so that this technology works. And then as things evolved, I became a network designer. I was doing network architecture, network design, doing a lot of research, sort of fundamental research in the networking space, because I was with Bell Labs for most of my career, so it's R&D focused. And so I did a lot of research on what's the next good thing, what's coming down the pike. And the networking includes everything. It wasn't just wireless, which is the preponderance of my background, but also included wireline, because most people don't realize that the wireless network is mostly a wireline network. And so you have to have a very good background in wireline, especially when you're doing things like end-to-end performance and so on. So I evolved from I'll call it a software engineer to a network engineer over time. And that's where I am now. And by the way, we've been using AI for a long time. It's just that now it's become a marketing term.
Yeah.
So everybody's producing things that aren't AI, but they're putting the AI label on it. But we've actually been doing real AI for a long time now. Doing things like optimizing the RAM, using, for example, ORAN. In the past 10 years, using Open RAN and the RAN intelligent controller to do AI at the very edge of the network, and also using AI to do efficient net ops. And so we were able, for example, to I don't say eliminate, but reduce the requirement for lots of people at the tier 1 and tier 2 level in network and net ops by using AI and smart operations. So we've been using it for a while, and now it's evolved to the point where we just have faster machines. Our chipsets are faster. We have GPUs. We can virtualize the network components, and then we have a lot of flexibility in how we implement AI at the edge. Right? So think about ORAN, Open RAN, for example. I was one of the original founders because I was with AT&T, and AT&T was one of the original founders of Open RAN. And we actually built the first near real-time RIC with Nokia. So I'm I'll call myself the father of the RIC, but it was actually myself and some folks at Nokia where we actually built the first RIC. But that's all about AI. How you use AI to do things like power optimization, QoE optimization, and lots of other things at the edge of the network. So that's kind of at a high level my evolution. I've always been managing large groups of people. So I've always been interested in getting the best out of people. I don't call that my forte. Seeing what people are good at or have a lot of interest in, and then coaching them to the point where they achieve their goals. And so my experience is that you get a much happier set of people when you do that. And that's kind of what I'm doing now. I've got recruiting the best and the brightest people, some former colleagues at the labs, some people that work for places like Lockheed Martin, Skunkworks, various laboratories in NASA and others. I've got a bunch of smart people now, and we're going to do a lot of exciting things using AI and networking, next gen networking.
So,
One
so
area,
I'm going to dive in. I
yeah, go ahead.
spent
Yeah,
4 years at Quest Communications, so that's the extent of my history with Telecom. But what I
uh-huh.
wonder is that your decision to build Adapnet was the company, was that driven by the changes and the faster machines and all the things you mentioned, or did you sort of have that, and how much has changed um, on your vision since the whole explosion?
Well, that's a good question, but basically it's opportunity. Um, when you're working for large companies, the opportunities are there, but it's a lot slower to get there. And so I see a lot of opportunity, but I want to get at it faster.
Yeah,
So
yeah, yeah.
that's kind of what drove me to do Adapnet, right? Because within a big company, you've got a lot of decision makers, and a lot of them are pointing in different directions. So I thought to myself, I've got so much experience and I've got a good network of people. Let me do this stuff and let me do it faster and better. So that was the idea. And so that's what we're going to do.
Yeah, and
Um,
people need the help.
yeah,
We talk to dozens and dozens of people every month, and the uniform issue is that people cannot separate the hype from the reality. They don't have confidence in their internal staff, in the figure it out department, and many, to be fair, already have day jobs that they
yeah.
need to perform in, and so they're this area of like, where's that kernel of expertise going to come from that's going to help me, is a huge opportunity.
Yeah, that's pretty much it. And of course, there's a lot of really talented people that get lost in big companies, and uh, we're gonna get together and we're gonna build some exciting things and not have to wait to do it.
That's
And
fantastic. Let me
yeah,
throw one other thing in, question out there for you, just because I've been thinking about this, and I appreciate and I've got a longitudinal career, I'll call it that as well. So I appreciate that you have witnessed all these stages of technology, and I've always been technology curious, even as a business person. So I sort of try to figure out, like, where's this whole thing going? And it feels like to me that, we started off writing custom code, and then that didn't scale. Nobody could afford software, and so then we went to, and software as a service came out, and we went to packaged products, and then we abstracted that even further and started using metadata to render applications. And I feel with AI, it's going back almost to the metal, right? Now you can have that fully custom solution written in custom code specifically for you, and you're not stuck with, to your point, somebody else's roadmap, somebody else's decision making, a use case that only you need.
well, so we have a similar approach in that we're going to use something called so as part of my doctorate work, um, I developed something called HLM, a human learning model, and what we're planning to do is basically use networks of HLM. I call the product Adapt One. That's our AI product. It's based on this HLM that I developed. And basically using a network of HLMs to build the infrastructure that we need. In other words, to build the code. And we see the code as ever changing. So just like a human being has code that they've written, and then over time they do maintenance on the code, the HLMs are going to do that. Okay, but human beings not doesn't have to be involved anymore, right? So now so think of it this way: you've got a network of HLMs. In our case, it's a network of adapt ones. They're learning like a human being learns. So you put them into a particular domain, they learn that domain, they write the code for that domain, and then they communicate to the other HLMs about what they've been doing. So you wind up with a network of HLMs, and instead of having a network where, let's say you have 10,000 locations and each location has the same device with the same software version running. Now you've got HLMs at each of these locations, but each site has their own code maintained by that particular HLM. And it's not necessarily the same release. Doesn't even have to be based on the same technology. It could be a completely different, let's say, code base. So that's what we're doing. We're kind of building HLMs to be smart and do the kinds of things that humans would do, but now we're evolving that to let's see what we need to do on a per location basis and let the HLMs decide and let them communicate to the other sites. So it's not going to be this model anymore of here's a release, everybody do an upgrade. We
Yep.
have the same set of features at each location. That's gone. It's going to
Yep.
be what's required at that location, and the HLM is going to take care of it.
And when, and
And when, yeah, and
which
when.
is great because I really feel like AI is ultimately, hopefully, going to help distribute software. Like you're
It
going to
is.
get away from these gigantic centralized software companies that really drive everything.
That's exactly what I'm saying. Exactly what I'm saying. So the HLM. Now you have to be careful. Uh,
I'm
one
not
of
a careful person, Mike. I'm not. I'm a startup.
the one of the things. Well, when you work in the telecom and you have to hit a 5 nines reliability target, you have to make sure that you can do that. And the software reliability is a big part of that, right? Now that's a big issue with AI. Most people don't realize this, is that uh, when you have problems in the field, basically you're going right to tier three. You're not, there's no more tier one and tier two because AI has replaced tier one and
Yep.
tier two. Now you go right to tier three, but tier three doesn't know anything about the code, right? Because the AI wrote it. So that's the challenge, and we're working on that. We're developing models for tier three and tier four support using AI in NetOps, so that when there is an outage, it doesn't last more than a couple of seconds.
Yep.
Because when you're talking about 5 nines, 6 nines reliability targets, you can't afford one. And that's going to be a big challenge with AI and telecom, or even enterprise services, where particular enterprises have high reliability requirements. So we need to keep that in mind, and people are forgetting about that part of the equation, right? So everybody's going crazy, going, yeah, AI, yeah, let's write the code and so on. But yeah, we need these other things to make it work. Tier
Yeah.
three, automated tier three and tier four is a big part of that.
Yeah, 100%. We have 100 developers in Argentina, and my CTO is a genius. He's the brains of this operation, and I talk to him all the time about like where is it really? Where is AI really? And he tries diligently every time. He's like, well, this is where it is, and this is where it isn't, because you have to know. But and this is sort of the communication that's not necessarily getting into the C-suite. They haven't really invested the time in many cases to say, hey, I need to have an intrinsic understanding of how this is going to upend what we do every day. They just say AI, go do it, and people are frustrated.
Now, I always tell people if you want a good job going forward, don't look for a software development job where you're doing the initial code drop. Look for the tier three to tier four role. That's going to keep you employed for a fair amount of time because right now the AIs can't do it.
Yep.
But we're going to do it. We're going to build it, so we're going to do it. So I got sort of this 5 year target on that because it's a complex problem.
Yeah.
Uh,
Yeah.
but
And
in those
and
5 years, these people can be very well employed if they take jobs in that arena. So
and it seems like they're the ones that are actually going to build it because they know the
yeah,
edge cases in their
yeah,
heads, like sucking that intrinsic knowledge out of an engineer's head that just knows this stuff, in everybody's head for that matter. I have a good friend who was in, insurance IT and systems forever. And he says, the biggest problem is a lot of these older insurance companies regulated, they're riding on these old systems. Everybody's retiring or dying, and God isn't making new ones. Like, the kids aren't going to come out of college to work on this stuff. And
Yeah,
how do
so
you?
they're on the old IBM mainframes still,
Yeah,
you
yeah,
know. And that's a
yeah.
disaster waiting to happen.
So
So,
I have
so
to ask
when,
you. Go ahead.
no, you
Yeah.
go. I
Well,
mean,
I
yeah.
would say one of the interesting things about one of your offerings for Adapnet is media forensics.
Yeah.
Uh, Tell us about that and who you see primarily this kind of work, who you'll be doing it for them, whether law firms, security teams, or media companies, and what are the most common kind of fires you anticipate putting out with that technology?
Okay, so as you know, everybody has a phone. Um, and as we move forward in time, video is becoming a big deal. So we're talking mostly, yeah. So we're talking mostly about video forensics, but it's not limited to that. We'll do forensics in any type of media. Um, and so you've got law enforcement, you've got military, you've got um, private investigators, the whole slew of people that need video analysis or media forensics so that they can get to the root of issues. And you wouldn't believe the types of customers we get. Law enforcement is one of them. So when you look at video that people have taken of particular crimes and you need to understand how things evolved over time, and so you look at what's happening within the video. You use AI to understand a lot of that and then put the pieces together and see if you can come up with a timeline uh, in the video itself that leads to the crime. Right. So that's a small example of one. There are other weird things that we get. Like we got a request from the DoD to look at a home video that um, it first came from the Las Vegas Police Department. Then it came from the Department of Defense, where supposedly a meteor landed in the backyard of somebody's house. They called 911 and said there were entities in the backyard, like they called them aliens, right? So they thought a spaceship had crashed in their backyard. It turns
That's
out
called
that
tequila, by the way. If you didn't know
what's that?
that's called tequila. Uh,
Tequila.
that's
So
what that's called.
so it turns out that there was some technology that the government was using that apparently was in the area. And it was concerned by the government that that technology had crashed, and they didn't want anybody to get hold of it because it had all kinds of secret stuff on it. So they asked us to do a analysis of all the videos in the area. So we were able to get various ring videos. We've got videos from the family. They had taken a home video. We got the body cams from the police, and we put together a study and came up with some very interesting findings. Um, and I can share the report with you if you want, if you're interested in it. But
I want to work for you, Mike.
yeah,
Yeah, hey, buddy.
it's really it's really weird. It's really strange. But my point is that media forensics is really important because video is becoming more and more important every day. And just about every entity that you can think of, from government to private business, with let's say security around their offices or their buildings, um, everybody's using it. Um, Even astronomers are using it. There's a lot of video now in astronomy. They do analysis of what's going on in the galaxy and the universe. So there's a lot of things that move around in videos, like planets and stars and other things. And so we get requests to do studies on movements of different uh, objects in the universe, in the galaxy, for astronomers. So there's lots of different use cases.
It's
And we
it's interesting. On the
develop
other side of the conversation is that we're now entering the era of, well, you can't believe your eyes. You cannot believe your eyes.
Yeah, that's
You
one
know,
of the challenges. Separating fact from fiction, separating AI from reality. And we have ways to do that that make these things bulletproof from a court of law point of view, so that we can walk into a court and be confident that the material that we're presenting is believable and based on facts versus something that could be easily made up using some sort of AI. Right? So you have to have a way to separate the variables, and we have ways of doing that, and that enables us to put some credibility behind the work that we do in the media forensics areas. So we want to be able to go into court and say, here's what actually happened, and and that's what we do. So this is a big area. This is a big business area. The problem is the reason why it's last. When I say next generation networking, computing, AI, and media forensics, is that we're so busy with the first three that I'm trying to figure out how I can tackle the fourth one, the media forensics, and still grow the other businesses. And that's a challenge just from a business point of view.
Are you
'Cause
building 100% bespoke solutions, or do you have any? Are you developing any assets that are reusable that are going to help you scale?
well, Adapt One is one of them, right? Adapt One, my HLM, that's going to help me scale because HLM is inventing things for us, as we do things, right? So it, we're able to use our own technology to generate things that we'll need down the road. In particular, that will help us scale because we're not going to be able to do it by ourselves or with staff. Um, and there's other ways of scaling. One of them is we're using money, but the problem with using money to scale is you eventually run out of money, and then you fall off a cliff. So you make investments using money, and then the money runs out, and then your scaling program goes to hell.
Yeah, no,
Right?
we are evolving our low code platform to be a framework, an open source framework, and this is why your Linux, your Red Hat background was so interesting.
Yep.
Because we see that in this new world, it's the value's not in the code anymore. The code's not the IP. It's what's in your head and your ability to stitch this stuff together. That's the value.
Yep. It is. But think about the possibilities now. The possibilities are endless. Um, but as humans, we can't discover all the possibilities, right? So we need AI now. It's no longer just AI as a neat technology. We're going to go use it. Yes, we actually need it now to move forward. We need it to scale. We need it to generate new ideas. We need it to help us generate new technology. We can't do it now by ourselves. Those days are over. And so as we move forward, there's going to be a lot more dependence on AI to do those kinds of things for us. And just think about what's happened over the last 20, 30 years. I worked at Bell Labs. We had the best and brightest people on earth. We were doing 1,000 patents a week, right? Because we had all the smartest people and we were doing fundamental discoveries. But the way businesses work now is they don't do that anymore, right? They have R&D organizations, but it's really just the R&D organizations are really just the best and brightest people helping to develop new projects and new systems. It's no longer R&D to do fundamental discovery,
Yeah.
right? So we need to do that now. But if we're too busy doing projects with our best and brightest people, we're not doing that. So how do we do it? Well, here we have AI comes along. So that's the hope of the future, is that the AI is going to help us do that. Just like in medicine, we need AI now to help us figure out how to cure cancer, right?
And to bring costs down.
And to bring costs down. So it's no longer, well, AI is neat and great. No, we need it And it's going to help us make those discoveries so that we can have fundamentally leaps forward in technology and how we do things. Right? So I want to be part of that.
I do too, you know, I think there's enough, because I don't see myself ever not working in some way, shape, or
all the
form.
time. Yeah.
And I think there's a way to, you know, with a longitudinal experience and practical understanding of where things are going. I think there's a way to operate in this new world for many, many years, even for old people like me.
Oh my God, there's so much opportunity. You just have to want it and you have to go after it. You know,
Yeah,
that's
and
it.
100%. And so we have, you know, I call them kids. Anybody that's under 40 is a kid. But we have people in Argentina, and they start off as, you know, maybe data analysts, right? They're doing some swivel chair, they're doing the ticky spreadsheet stuff. Guess what? They're great prompt engineers, you
Right.
know, and they like the work, and they're so focused on just that part of it that the rest of the developer staff starts to trust them more because they're understanding more about the machine. Then it's very interesting how this is all going to break apart and create new career paths.
Yeah, like another example is Adapt1, the HLM. That guy figured out how to do um, data analytics beyond the way that a human brain does it, and came up with a neural network, a neural structure that um, the neuroscientists and neurologists and people that look at the human brain and try to figure out how it works beyond what they've been looking to do. So it came up with sort of structure of what a new brain would look like, right? So I shared this with one of my colleagues who happens to be a neuroscientist, and he was like, he was dumbstruck. He took that discovery by Adapt1, and now he's working with his colleagues uh, to see how moving forward, how the human brain works, and how certain diseases of the brain might be cured based on the way the brain structures itself and evolves. It's really a neat discovery that Adapt1 made, and I'm really proud of it. It's nothing. I had nothing to do with it. It was just Adapt1 understanding the world, taking data that it understood from various inputs, um, and then building its own neural pathways so that it could do additional analytics. And the way it did that building of the new neural pathways was very similar to the work that neuroscientists are doing to understand the evolution of the human brain. And so when I shared that with my friend, who's a neuroscientist, he couldn't believe it. So that's true AI. AI is not just solving complex problems. AI is, you've got an entity that actually is thinking and coming up with new ways of doing things. I was blown away because I developed this thing, and it's kind of scary in a sense, but it's kind of exciting in a sense too. So.
Well, my sister has multiple sclerosis, so she has neural pathway problems all over the place. And there's a lot of hope now, given that, sure, there's some relationship to gut biome and whatnot, but how do you survive? Is there a way to reroute this
There is.
to new external neural pathway so that it can actually, you're thinking about it, it can move down to your foot?
Yeah, well, I don't have expertise in that area, but apparently my AI does. And, those are the kinds of things that are going to start happening. We're building these systems, and they're going to start to do things that we didn't know about or never dreamed that they would do. And as you see that come to fruition, you're like, oh my God, it really does. It really is an AI. And so that's the exciting part of this. That doesn't happen a lot, but it does happen, and it's just amazing. So that's why I'm so excited to be building this enterprise, because these are the kinds of things that I'm going to see and that I'm going to be involved in, and we'll be helping mankind move forward. And that's what I want to do.
Well, it just seems since the dawn of mankind, we have, we've created data and information, and generation after generation, especially now in the digital era, all the Library of Congress's information that is exported on a daily basis, and now AI has that ability to create a solution based on the accumulation of that data. It is an exciting time to be alive.
Yeah.
So we're kind of hitting the end of our time. I just want to pause for a second. Is there a question that you'd like to have asked of you? Maybe something about Adapnet or anything that you'd like to talk about in that realm?
Well, I like to promote my company. And again, a little bit about myself. Uh, I was born here, Kearney, New Jersey, and we moved to Italy when I was an infant. So I went to school there. Um, Came back to the States during high school years, um, and but all my family and friends were back there. So we're building. Um, over the years, a lot of my former friends and colleagues from school back there also got interested in technology. So we're building this company on two fronts. The headquarters is actually there. It's in a little town called Casalvieri in Provincia di Frosinone, which is about an hour and a half south of Rome. And we're going to have probably offices here on the East Coast and maybe one on the West Coast, just to start off. Um, and we've got a backlog already of projects. I think we're going to focus on the next gen networking piece initially, because most of the work that's coming in is in that domain, and a lot of it is on the RAN, the radio access network, and optimizing the RAN. A couple of things that are very big on the RAN, power optimization is a big one. So everybody wants to be green. Um, we have unique ways of doing that with Adapt One. You'll hear a lot about that from other companies and other people that are doing supposed green projects with their technology. But we have a unique way of doing green, such that we have substantial power savings. The big issue with AI is power consumption. We have a way of doing true AI with a net reduction in power consumption, right? So I'm writing a paper on that. That I'll be able to share. It'll be right now. It's under peer review, so it'll be published sometime at the beginning of next year. But basically, it's a breakthrough on how you do advanced AI, but you have a net reduction in power consumption. And that's a big deal because what's happening right now is there's a lot of data center build out with a lot of electric infrastructure right next to it. That's a problem.
Yeah.
Okay, we're supposed to be cleaning up the environment,
Yeah.
and cleaning up the world. That's not doing it,
Yeah, and
right?
they're making it more expensive for the humans.
Yeah, and so we're going to have a way of doing this, and that's going to be a big deal, right? And we're anticipating that we're going to have a lot of success in that area because there's a lot of interest in it. Nobody's figured out how to do it yet. Well, we did, okay, and um, and that's what we're going to do. So that's where the initial focus will be. It'll be on these optimizations on the RAN, including the power, and how do we do end-to-end network operations in a way that's cost effective and power consumption effective. The next step beyond that is next generation computing. And what we mean by that is quantum computing, quantum communications. One of the things that we've been working on is a big deal on the RAN is latency. Okay. You'll hear things like, oh, we can do 4 milliseconds round trip latency of a packet. And we're like, no, you can't. Not with, not when you're talking about the RAN and the core and all of the pathways that a packet has to traverse in order to do that. You need fundamental physics uh, implementation, uh, quantum communications or quantum entanglement. Well, nobody knows. We know how to do that theoretically, but nobody knows how to do that practically. Well, guess what? we've got a team of physicists and computer scientists that are working on that, and we're going to figure that one out. So we think within the next 5 years, we're going to have a way of doing close to zero uh, millisecond latency. That's
Wow.
going to be that's going to be a breakthrough.
Wow.
Okay, that's going to allow us to do applications over the network that we've not been able to do, including end-to-end surgery. Okay, one of the big problems with doing surgery today is the latency, and so the haptic feedback that you get is not true. Okay,
Yeah.
so the surgeon is going to feel something, but it's not true. So he's going to do something wrong. When you get it down to 0 millisecond latency, it's a true haptic feedback. Now you've got very reliable surgery. You can do it from anywhere. So within the next 5 years, um, we think we can solve that problem. We're not going to get it to zero, but we're probably going to get very close to zero. And we
Let
need
me ask you,
physicists to do
I,
that.
I
Yeah.
gotta ask you this. Do you think the existing global network providers are gonna be able to tool up to, or do you think there's gonna be a whole new breed of people that buy the fiber and stand up their own devices and networks, and those people are stage one rockets getting dropped into the ocean?
Yeah. I mean, just like Elon Musk did, you know, you're going to have a set of entrepreneurs that are going to bypass the, the global network providers, right? I'm going to do that. I don't need them. I want quantum computers or very high speed computers with GPUs or advanced GPUs and even beyond that. I'm going to deploy virtual components wherever I want to. I'm going to orchestrate them wherever I want to orchestrate them. I'm going to have the lowest latency. I'm going to be able to provide all the services that they provide. I don't need them anymore.
Yep,
Okay. Think about
yep.
this: when you do a find, when you try to find your phone, have you ever done that? Well, that uses everybody's phone. So somebody standing next to you, let's say you're home, but you lost your phone at the mall. Okay, so you do find. Well, it's not going to go to the cell tower to do the find. It's going to go through everybody's phone along the way. So if there's a pathway of phones, it's going to find your phone that way. So one of the things that telecoms have been working on, and places like Google and other places are working on this, how can we do that with regular networking and transfer packets and do applications such that we can transfer packets over people's phones in an encrypted way and not have to use cell towers?
Kind of like blockchain.
It's like blockchain. The problem is the power consumption again. You're going to drain the batteries of the phones like within 5 minutes, right? So we're figuring out a way to do that without running down the battery, so that you can build any network you want, anytime you want, using the billions of phones that are deployed around the world, right?
It
That's
makes
very
so much
exciting.
sense. It
Yeah,
makes so much sense to stitch all the resources together versus
yeah,
the whole centralized, you
yeah,
know.
yeah. Or we'll stop to we'll jump to a cell tower if we need to, or we'll jump to a satellite if we need to. It's just going to be a set of very smart systems with virtual components, so that I'll be able to orchestrate things that I want to where I want them. But we need these we need these fundamental physics changes in order to get to where we need to get for applications in 6G uh, and other very high speed networks. We need to fix this latency problem. That's a big deal. We need to fix it. Uh, and we need to figure out a way to do computations much faster than we do now. And we need to be able to do all this with a much lower power consumption, right? So this is what we're going to do. This is what my company's going to do. Yeah.
Well, Mike, I'm gonna be rattling your cage at some point because I'm totally fascinated by this topic. But
Yeah.
Dave, I'll let you run your show. Sorry.
Yeah. Well, there's a reason why we call this podcast Smart Company. And I think, Michael, you and your company have definitely made the name of our podcast all the more accurate today. And I just can't thank you enough for coming on and joining us. Tremendous insight, very excited for you and your new company and its new opportunities, and of course, excited for humanity. You've made me even more excited about what's around the bend concerning AI, and so I thank you for sharing all of your insights.
Well, I certainly appreciate it. I love doing this. I like talking about technology, what we're going to do with it. It's very exciting to me, and I think it's exciting for the world.